yesterday, this is what we did. I hope if you have looked at the notebook, I gave you a task here. I asked you to think about how you can identify a data type as mutable or immutable without using the ID function. What's another way to identify a data type as mutable or immutable? All right, so Abhilash says mutable means changeable and immutable means unchangeable. Well, that's right. I'm not asking the meaning. We discussed the meaning yesterday. You're correct in the meaning. Jayant says by using type. Type will tell you the type of the variable, like a list or a set or a Boolean or whatever, right? Fine, okay, let me show you how you can identify it. It's very simple, all right? It's very simple. If a data type, like a list or a dictionary or a set, we know that it's mutable, but how do we know is the question. Well, we know because these data types provide methods that let us change the values in those variables. It lets us change the contents of that variable, like pop and append for lists, okay? And for dictionaries and sets also, we have similar methods that allow us to change the contents of the variable. So very simple, it's mutable because it has these methods. How can you find out about the methods of provided by a data type or an object in general? How can you know what are all the methods available for that object or data type? I'm going to rerun the notebook because I just loaded it from yesterday. dir, yes, dir can do it. Also, there is help, okay? So you can do help list. If I run this, it tells you a little bit about the list data type. It's a class, of course, and you make objects out of the list class. And these are all the methods available. And remember, any method that starts with a dunderscore, a dunderscore is a double underscore. So anything that starts with a double underscore or even a single underscore is something you should not use directly, at least most of them, okay? So these are to be used internally by that class to support certain functionality, all right? So if you've done object-oriented programming before, in Python especially, then you will know what init means and a few others what they mean, right? You may know about many others as well. But the ones that you should directly use are things like append and clear and copy, count, extend. There are so many, right? Including pop that we demonstrated earlier. And then there is remove as well, which is a little bit different than pop, okay? So if anything provides you with a method that allows you to change the content of that object, it is mutable. And similarly, we can do a help on, let's say, bool or int or whatever, okay? And we can check this. What are the methods available for bool? So methods available for bool, if you check, there are no methods that you can use directly, okay? All these are internal methods, and you won't see any method that you can actually use directly, right? I mean, there are some like bit length and conjugate and 2 bytes and a few others, but basically these are kind of informational methods. They don't really change anything in the object, okay? Does that make sense as to how to know whether a data type or object is mutable or immutable, right? You can do a help, you can do a dir, and check the methods and see if there is any method that allows you to change the content of that object, then it's mutable. If there is no method that allows you to change the content of the object, then it's immutable, simple, okay? What's the difference between a tuple and a list? If you have worked with tuples and lists, you'll know that they are very similar. Okay, so one is that tuple is immutable and list is mutable. Okay. In terms of methods, of course, that means there will be difference in the methods provided by a tuple and a list. When should you use a tuple? When should you use a list? Or can you use them interchangeably every time? Use tuples when you know that once you assign a certain content to a tuple object, the content will not change. It has no need to change. Then use a tuple. If there is a use case where you know that you have to assign certain elements to a list and that list will grow or shrink over time, then of course use a list. Okay. Let's go back quickly to the slides. And okay, so we are done with variables. We know what are variables, different types of basic variables, okay? And we know the naming rules, of course. So you can look this up in the documentation later. And we know the kind of sequences that are available in Python, like strings and tuples and lists are sequence types, right? We know about selection statements like if, else, and elif. We know about operators like mathematical operators and comparison and Boolean operators like these, okay? Now, you also know about repetition statements, keywords that help you control the flow of your logic, okay? So keywords like for, while, break, and continue. And I also expect that you understand the differences between, between keywords and functions and identifiers, similarities and differences. When it comes to keywords, there are what, 34 keywords in Python 3.7. 3.7 is the one that I'm also using. 3.8 is the latest, but I don't think any keywords have been added from 3.7 to 3.8. So I think it's still 34. But out of all the 34, these are the absolute bare minimum that you have to be completely comfortable with, okay? The others you can learn in time, as and when needed, but these are the keywords that you have to be absolutely comfortable with, okay? These start from the true and false, which are also values that you can assign to Boolean variables, as you know, like we started in the lab, right? But these are also keywords. And then there is the none, which is also a value. It's also a data type. There is a none type data type, okay? And none is a value. It's also a keyword. Then there is and, or, of course, not, break and continue, def for making your own user-defined function, if, else, and elif, okay? For, while. Then you have in, import, return, with, delete, that's del, and lambda. So these are the absolute basics that you have to know. And when it comes to built-in functions, also there are many, many built-in functions. You can check the official documentation for the entire list of built-in functions in Python. But again, these are the absolute minimum that you have to know, okay? These include things like print and input and ID and type that we have already seen, right? And some others. So built-in functions are basically functions that don't require importing any module. They are built inside Python, so to say. So the problem statement goes like this. This class starts when a certain number of students have joined, okay? Until then, we wait. And so what you have to do is write Python code to simulate this scenario. Student count equals 0. This is an integer variable, as you can see, and then I'm making a class started variable. That's a Boolean variable. I will set it to false. And then I will create a loop like while class started equal to false. Okay, I will check if student count equal to 5. That should be a parenthesis. If student count equal 5, I am taking this certain number of students as 5, okay, just for simplicity. So if student count equal 5, then set class started equal to true, else I will print waiting, and I will set a variable called student or students joined equal input did a student join. So remember, this is a simulation. It should be interactive, it should simulate the scenario basically, right? So that's what we are doing. Yes or no type of question, and we'll get the response here. We'll store it in students joined. And then what I do is if students joined equal to yes or y, then I say student count plus equal to 1, and then I'm pretty much done. I can, outside the loop, I can print something like great, let's start. So I run it and it asks me, did a student join? See, currently student count is 0, class started, it false, and so this condition does not meet. It comes here. It should say waiting before this question, but that's okay. That's just a Jupyter Notebook thing. Don't have to worry about that, okay? Basically, waiting is before this question. Anyway, so I'll say no, and it'll still say waiting. I'll say yes, yes, no, yes, yes, and yes. And now it is equal to 5, so it says, great, let's start. Look at this code and tell me ways to optimize this code. Now, this is very, again, important point. Once you have solved a problem to meet the problem's requirement, then you go on to optimizing it, not before, okay? That is very poisonous to try to optimize something before actually solving it.